All right. So this morning we're doing simultaneous equations. Which we've done before. Alright, simultaneous equation. So the solution of simultaneous equation tells us what?
Pardon?
What does the solution to simultaneous equations tell us?
That there are multiple answers. I don't know, sorry.
Tells us when, or I should say, where lines intersect.
Correct.
All right, so there is three methods for solving. Substitution is one of them. The second one is elimination. And the third one is using the CAS calculator. Alright, and when we're doing it on the CAS calculator, there's two ways we can use. We can use the template, or we could do a graph. Now on the exam, it mentions in the study design, so you could be asked to do two variables. Max by hand. So algebraically. Alright, so if there's just two variables, x and y for example, then you could be expected to do it by hand using either substitution or elimination. If there's more than that, then you would use your calculator. Alright. Alright, we got that. I want to rub it off. Alright, now there are three possible solution options. One is that we have what's called a unique solution. In other words, we find out where the lines intersect. There we are, so there's our solution. The second option is that we would have no solution. And so if we have no solution, what does that tell us about the lines?
They don't meet.
They don't meet.
Don't cross.
They don't cross.
Don't.
Something else we can tell about
They're
them.
parallel.
Parallel.
Good job, Jack.
All right, so we have parallel lines. All right, and the third option is if we have infinite solutions, which seems to be a strange concept. Can anyone guess what that might mean about the lines if there's infinite solutions? The same, yeah, so two copies of the same line. Alright, so one would be like that, and then the other one would be right on top of it. Like that. So an example might be something like this, for example, y equals 2x plus 1 and 2x minus y equals negative 1, for example. All right, these two, while they're written differently, they're actually the same line. They've just been rearranged. All right. Okay, a couple of examples. All right. So the question asks us, explain why these two equations have no solution. So we would suspect if they have no solution that they are parallel, and if they are parallel they would have the same gradient. So what we need to do is just check that that is the case. Hopefully I've written my thing down correctly. Have I? No, I haven't. That should be 3y here. Sorry. So 2x plus 3y equals 6, so let's take 2x from both sides. Minus 2x plus 6, then divide everything by 3. And the other one, take 4x from both sides, divide by 6. And 4, 6, of course, 2 goes into both of those, negative 2/3 x plus 4. So why don't they have any solution? Because they have, excuse me, same gradient. But the same gradient is not enough. What do you notice about these other numbers? They're different. What are those other numbers?
Y-intercepts.
Y-intercepts. So for our lines to not intersect, yes, they have to be parallel, so they have to have the same gradient, but they also have got to have a different y-intercept, because if they had the same y-intercept, they would be the same line. Therefore, they're parallel. And no solution. All right. So the question comes about if we've got an infinite number of solutions, how do we write those? So we'll do an example of that.
So two.
All right. Okay, am I right to rub that out?
Wait, what's this in it? Just the last part.
Just the last part?
Yeah.
It's right next to you.
Okay. So this one here says simultaneous equations 2x plus 3y equals 6 and 4x plus 6y equals 12 have infinitely many solutions. And so when you look in the second one, each of those numbers is just twice what it is over here. So these have one line on top of the other, so there's many solutions. Now, so the question is, how do we write that? Well, as it suggests here, we use what's known as a parameter. So what's a parameter? It's just a symbol of your choice. And often we use, and we're going to do that, is we use Greek letter lambda. All right, so what I'm going to do is this one on the calculator. Let's see what the CAS calculator gives us.
Is that the symbol that you use?
That's our symbol that we're going to use, so lambda here, this here will be our parameter we're going to use. We're going to use this as our parameter. Oops. All right. So CAS calculator, here it is, main, our template is here. So let's put our 2x plus 3y equals 6, and then the one under that will be 4x plus 6y equals 12. And going across, we're going to solve it for x and for y. So when we do that, this is what our CAS calculator, let me put it in not decimal but in standard. That's better. Our CAS calculator gives us this. So it gives us it in terms of y. So it says that x is equal to negative 3y plus 6 over 2, and y equals y. Let's swing this back. Now, in a question here it says describe solutions using parameter, but here our CAS calculator's just given it to us in terms of x and y. So bring the parameter in. What we do is we look at what x is equal to and what y is equal to, and whatever it's equal to, we use a parameter. And seeing as this one here, the y is just by itself, excuse me, I'm going to, and the y is in here, I'm going to replace that with the parameter. So using lambda as the parameter, we would say that x is equal to negative 3 lambda plus 6 over 2, and y is equal to lambda, where lambda can be any real number. All right, so you might think, well, what does that do? Well, it actually connects specific x and y values together. Because the x and y values, that coordinate has to be on those lines. It can't be just any random coordinate anywhere. And so the parameter ties those two things together. So if lambda's 1, then the y value for the point of intersection is 1, and the x value would be 3 over 2. So that's a specific point. All right, we'll do one more. 3. Any questions about that? No.
So we use the parameter, so it's not like y equals y.
So it's not y equals y, you make y equal to the parameter, and then you replace the y in the x one with that parameter. Yep. All right, can I rub this off?
Yep.
All right, one last example for 3. All right, so here's 3. Now, as I said, the study design specifically says that by hand, maximum of 2. So we use our CAS. All right, so let's have a look at how we would do that. All right, so we still use our template. Click on it, you see it only brings up 2, we need 3, so you click again. It brings up a third. If you had 4, you click again. And then you just type in each one of those. So the first one was x minus y plus z, I think, yes, equals 6.
It's x plus y.
Okay,
X plus y.
x plus y. The one underneath, 2x plus z equals 4. The one underneath, 2x plus 2y minus z. And 3x. 3x plus 2y minus z. And that equals 6. And we want to solve for all. And then we go EXE. And then there's our solutions, 6/7, 20/7, and 16/7. Alright, that's it for simultaneous equations. Most of this we've done before anyway. Alright, any questions? No? Alright. Exercises 2F and 2G.